Good morning. I'm Devasena. In this lecture, we are going to discuss about nonlinear equalizer and its types. Need for nonlinear equalizers. When compared to linear equalizers, the nonlinear equalization technique provides less noise effects, but the cost paid for achieving less noise is presence of some amount of ISI, that is intersymbol interference distortion. The linear equalizers avoid the ISI distortion, but it allows noise enhancements. Both the types of linear and nonlinear equalization techniques have their own merits and demerits, and hence, depending upon the application and nature of the radio channel, any one of them is selected. Classification of nonlinear equalizers. Nonlinear equalizers are mainly used in those application areas where the channel distortion is very high for a linear equalizer to handle it, and this happens in wireless systems. The main types of nonlinear equalizers which are very effective and used for 2G, that is second generation and third generation techniques, are listed below. Decision feedback equalization, that is DFE. Maximum likelihood sequence estimation, that is MLSE. And maximum likelihood symbol detection, that is MLSD. Significance of nonlinear equalizer. When compared to linear equalizer, there is zero forcing and MLSE methods, it can be said that linear equalizers does not provide minimum noise enhancement but has good reduction of intersymbol interference, that is ISA distortion, produced by the random time varying natured channel. Hence, these nonlinear structures were given importance, and the decision feedback equalizers under it produces minimum noise enhancement at the cost of some amount of ISA distortion in the system. Block diagram of maximum likelihood sequence estimator MLSE is given here. Maximum likelihood sequence estimator decision feedback equalizer structure discussion. A simple structure of MLSE equalizer is shown here. It is said to be optimum since it reduces the probability of sequence error. It mainly needs prior knowledge about the characteristics of the channel so as to calculate the necessary metrics to make appropriate decisions. An adaptive matched filter is used in the nonlinear structure as above, which operates on the continuous time signal, but the channel estimator unit and MLSE depends on nonlinear sample for its operation. The ultimate goal of the nonlinear equalizer is to reduce noise enhancements. Block diagram of zero forcing decision feedback equalized communication system is shown here. Decision feedback equalizer. The problem of noise enhancements in linear equalizers can be reduced and the system performance can be improved by implementing nonlinearity into the system design. This is achieved by applying a decision feedback equalizer, that is DFE. The DFE unit makes use of the decisions made on the previous data symbols to cancel out ISA distortion that may affect the decisions on the present symbols, so that DFE tries to minimize noise enhancements. The demerit of DFE is error propagation due to feedback of incorrect decisions, if any. The DFE comprises of two main parts, namely the forward filter Q of Z and the feedback filter P of Z. The Q of Z includes either zero forcing or mean squared linear equalizer, where P of Z is intended to further reduction of ISI effects. These two filters Q of Z and P of Z play very important role to achieve their goal of minimizing noise enhancement problem. The forward filter will act on precursor ISI and the samples of the entire system response which occurs prior to the present time period. On the other hand, it does not make an attempt on the post-cursor ISI, the samples of the entire system response which occurs after the present time period. The feedback filter P of Z is a casual filter because it operates on the past decisions made on the symbols. It can be given as P of Z is equal to summation of k is equal to 1 to m q suffix k z power minus k, and it aims to cancel post-cursor ISI effects, where, as said before, the forward filter aims to equalize precursor ISI effects. The two DFEs and the nonlinear equalizers are zero forcing decision feedback equalizer and mean squared decision feedback equalizer. Another form of DFE known as predictive DFE can be realized in lattice structure. Here is a representation of predictive decision feedback equalizer PDFE. The predictive decision feedback equalizer PDFE consists of feed forward and feedback filter. The feedback filter is given by the input, which is produced by the difference of output of detector unit and the output of feed forward filter. The feedback filter is also called as noise predictor due to the reason that it predicts noise level and the ISI distortion present in the signal. The feedback filter in PDFE can also be realized as lattice structure. It hence tries to minimize noise enhancement effectively. Consider the block diagram of zero forcing decision feedback equalized communication system. The same can be employed to achieve a mean squared error decision feedback equalizer with a small change. In DFE MLSE method, there is no constraint as the filter Q1 of Z need not be exactly equal to 1 divided by G of Z, as in the case of DFZF method, and Q1 of Z will be determined with the P of Z, keeping a reduction of MLSE into consideration.
Thank you very much for listening this lecture. For further updates, kindly subscribe this channel. If you like this video, kindly share this video to your friends. Thank you.